Welcome to the second video in this solubility curves lesson. Make sure you've seen the first video where I talk about what the definition of a lot of the vocabulary terms used in solubility problems means, as well as where I talked about the general trends that we see in solubility of solids versus gases. Today's video is going to focus exclusively on practice problems using the solubility curve. So we are going to use table G to determine whether a substance is more likely to be a solid or a gas, just from looking at table G, to describe what happens to the solubility of a given solute when the temperature increases, and determine the mass required to make a saturated solution of a given solute, given the temperature and the mass of water we are using. For this first question, based on what we talked about in the last video about how temperature impacts the solubility of solids versus gases, I would like you to predict which substances are gases and which substances are solids just from looking at their solubility curves. So take a moment, take a look at table G, list out all of the compounds that are given on the table, and think about whether or not each one represents a gas or a solid. We'll take 30 seconds to think. Pause the video if you need more time. So the key here is looking at the solubility curves and thinking about whether or not they are increasing or decreasing as temperature increases. So in other words, looking across the x-axis for each of the curves and thinking about what is happening to the y value, the solubility, as the temperature at the x value increases. So I just went ahead and color-coded each of our solubility curves here to represent which curves are increasing, those are the red ones, and which curves are decreasing, those are the blue ones. Think about if that hint helps you, if you weren't sure. Think about that. Because hopefully you remembered that if solubility increases as temperature increases, that means we have a solid, most likely. Whereas if solubility decreases as temperature increases, that means we most likely have a gas. Because in order to dissolve a substance, solvent, in this case water particles, need to be able to come in and surround the particles of the solute. For a solid, that means the particles need to be separated from the other solid particles. More energy, higher temperature, more kinetic energy helps that process happen faster, making the solubility higher. For gases are already moving really fast. In fact, they're moving much faster than liquids. So gases actually need to slow down in order to be able to be dissolved into a liquid. So for gases, they're more able to dissolve when the temperature decreases. Again, watch the last video again if you're not completely clear on that. A sample of normal rainwater has a pH value of 5.6 due to dissolved carbon dioxide gas from the atmosphere. Acid rain is formed when other gases, such as sulfur dioxide, dissolve in rainwater, which can result in lake water with a pH value of 4.6. The equation below represents the reaction of water with sulfur dioxide gas. Based on table G, describe what happens to the solubility of SO2 gas, sulfur dioxide gas, as the temperature increases from 10 degrees to 30 degrees at standard pressure. So pressure is going to remain constant here and temperature is changing. The 30-second timer is counting down to when I will start to go over the answer. Pause the video if you need more time than that. Let's practice reading table G. First, I'm going to find the line that represents sulfur dioxide. Not as intimidating as it seems. That's the only line that I care about on this particular table for this problem. I also am only going to focus on the range from 10 degrees Celsius to 30 degrees Celsius on the x-axis. And I'm going to notice that the curve decreases as the temperature increases. Specifically, it decreases from about 18 grams per 100 grams of H2O to about 8 grams per 100 grams of H2O. So at 10 degrees Celsius, the solubility of sulfur dioxide gas is approximately 18 grams per 100 grams of water. As the temperature increases, the solubility decreases to approximately 8 grams of sulfur dioxide per 100 grams of water. So I would say the solubility of SO2 decreases as the temperature increases. Let's look at another question. At 23 degrees Celsius, 85 grams of sodium nitrate solid are dissolved in 100 grams of water. Based on Table G, determine the additional mass of sodium nitrate, NaNO3, that must be dissolved to saturate the solution at 23 degrees Celsius. Again, here's the 30-second countdown. Pause the video if you need more time to think about it. This is really just about reading this table. So first, find the NaNO3 curve. It's right there. Second, find 23 degrees Celsius on the curve. So that would give me 90 grams of sodium sulfate, of sodium nitrate that can dissolve at 23 degrees Celsius. Now, if I know that 90 grams can dissolve, and if I know that 85 grams, according to the question, are already dissolved, make sure you're reading the question closely, right? Because the answer here is not 90 grams. The answer here is, well, there's 90 grams required to make a saturated solution at 23 degrees Celsius. 90 minus the 85 grams I've already dissolved, an additional 5 grams of sodium nitrate should be added so that I can saturate this particular solution. I can just use the numbers on the y-axis because I'm talking about 100 grams of water, and that's what the solubility is also telling me about. A 100-gram sample of liquid water is heated from 20 degrees to 50 degrees. Enough potassium chlorate, KClO3, is dissolved in the sample of water at 50 degrees to form a saturated solution. So let's figure out how much KClO3 must have been dissolved to make that saturated solution of 100 grams of solution at 50 degrees Celsius. Again, you'll probably need more than 30 seconds. Pause the video if you do. So KClO3 is here on the solubility table. I'm looking to see how much KClO3 has to dissolve in order to saturate the solution at 50 degrees Celsius. So according to the solubility curve, that would be 21 grams. A saturated solution of sulfur dioxide is prepared by dissolving SO2 gas in 100 grams of water at 10 degrees Celsius and standard pressure. Determine the mass of SO2 in this solution. So I'm going to locate SO2 on the curve. I'm going to find the mass of SO2 in a saturated solution at 10 degrees Celsius. I'm going to find where 10 degrees Celsius intersects with the curve. And I'm going to match that on the y-axis. And so it looks like 15 grams of sulfur dioxide can dissolve in 100 grams of water at 10 degrees Celsius. Next question here. Based on Table G, state the general relationship between solubility and temperature of an aqueous SO2 solution at standard pressure. Now, based on table G, the general relationship between solubility and temperature seems to be that as the temperature increases, the solubility of the SO2 decreases. Since SO2 is a gas, the problem tells us that, this makes sense, right? Gases have an inverse relationship with temperature when it comes to their solubility. Finally, determine what happens to the solubility of sulfur dioxide gas when the pressure is increased at a constant temperature. So since SO2 is a gas, as the pressure increases, the solubility should also increase. Let's check back in on our learning goals. Hopefully you're feeling more confident about using Table G to answer Regent-style questions. Awesome job today.